Hi everyone, how are you? Students, in today's lecture we will discuss about habitable zone. Habitable zone. The habitable zone is a region surrounding a star where a planetary body like Earth would be able to support liquid water. If Earth were close to the Sun like Mercury and Venus, it would be much too hot for life to exist as we know it. The habitable zone is represented by this diagram. Similarly, if Earth were farther away from the Sun, like Mars' orbital radius, it would be much too cold for most life forms to survive. Asking where a planet can have liquid water, or more importantly, the conditions required to sustain life, is a fundamental question that many people have asked throughout human history. Astrobiologists, people who study both astronomy and biology, call this region the habitable zone. Students, there is some flexibility in the definition since it would include frigid planets where the maximum temperature is just above the freezing point of water and intensely hot planets whose minimum temperature dips just below the boiling point of water. Let's look at our own solar system and see where we would draw the boundaries of the habitable zone. Scientists believe that our solar system habitable zone extends as close to the Sun as Venus at just under three-quarters of the astronomical unit to as far as twice Mars orbit or twice 1.5 astronomical units. Arguments vary regarding what we consider normal life since we have examples here on Earth of extremophiles that can live at extreme temperatures. So we will just have to leave the boundaries of the habitable zone to what they are estimates. What if Earth were in orbit around a different type of star though instead of the G-type star we currently orbit? An M-type star like our nearest Proxima Centauri are the cooler red dwarf cousins of our Sun. Since they have a lower surface temperature, the habitable zone around it contract to a smaller distances. As this contraction is represented by this diagram. If Earth stayed at the same distance from a M-type star like this, as it is to our Sun, it would quickly turn into an icy snowball at the edge of the new habitable zone. On the If Earth stayed at the same distance from a M-type star like this, as it is to our Sun, it would quickly turn into an icy snowball at the edge of the new habitable zone. On the other hand, if the Sun were suddenly replaced with a more massive and therefore high temperature star, like a blue blazing B-type star like Bellatrix, the habitable zone would move outwards in the solar system, leaving Earth a burnt crisp. Students, this is all about this lecture where I have discussed about the habitable zone. Thank you so much. मोटो चावल खाला कि में आले आ